Hello and welcome to Dataiku Data Science Studio, the centralized, collaborative, and end-to-end platform for data science in the enterprise. We're beginning this demo on the homepage. Here, we can see all the projects from our team, as well as the latest items we've been working on, and different ways to collaborate with our colleagues, such as dashboards and wikis. In this demonstration, we'll be looking at a project built by a team from Dataiku to predict taxi fares in New York City. The project homepage shows who's collaborating on the project and the latest actions in the timeline. It also features basic info on the project, such as the number of datasets, models, notebooks, etc. We can add to-dos and start a discussion with the team. We also have general stats about the number of commits, the activity of each contributor, and recent changes and custom metrics about the data and the models. All of this makes it easy for the team and the managers to stay up to date on project progress. The end application of this project is an external app that calls the predictive model developed in Dataiku. You can imagine how you could build similar services for internal and external purposes. Let's see how much it would cost to go from our New York office to Central Park for a walk today at 3:30 p.m. Behind this simple interface, we had to source and prepare historical data, train a machine learning model on that data, and then deploy that model as an API. Let's go back to the full project in Dataiku to see how easily we did all of that. This is the flow, a visual representation of each step that takes place in the data pipeline. When we started the project, it was a blank page. From there, we built it into what you see here. First, we connected to the data sources. Blue squares in the flow are data sets. Second, data preparation. Yellow and orange circles are steps where we manipulate the data using the visual interface or using code. We call these steps recipes since they are meant to be reused. Red elements are plugins, which allow us to extend the capabilities of Dataiku. They are reusable across projects and can be shared in our plugin store. Then green is where the magic happens, where we apply machine learning algorithms to the data to train models and score the new data. This is Dataiku's design environment, where we can build and test solutions. Later, we'll delve into operationalization to see how to put the full project into production to serve the needs of the external application. We're now going to dive into the following 5 parts: connectivity, data preparation, modeling, operationalization, and inclusive data science. Let's start our project with the input data. We can connect to more than 25 data storage systems, including traditional relational databases, Hadoop, NoSQL sources, and object storage technologies. In addition, you can create custom connectors to any data sources. With Dataiku, the data stays where it is. You don't need to ingest it into a new environment, and you push the computation to those environments. This way, you can leverage the environments that you've already invested in. We're now adding some parking garage data to the project. This data will provide additional information and enhance the performance of our model. Dataiku samples the dataset and allows us to quickly begin doing an analysis and creating insights. We can always control how the data is being sampled to be sure that we're getting an accurate view of things. Much of what used to be a time-consuming task is now made quick and easy through the use of the Analyze dialog. Analyze allows us to view useful statistics on both categorical and numerical variables, or to create these metrics on the entire dataset. We can schedule those metrics to be refreshed and captured over time. This way, you can monitor how your data is changing without having to check it manually. Dataiku also offers a charting tool to quickly and easily create our own insights. Now that we have a good view of our data, it's time to get it ready to generate insights. Dataiku's visual recipes enable us to clean, enrich, and transform the data with a minimum of effort. Dataiku looks at your data and suggests actions in context for data analysis or cleansing. We can preview the outcome of every change we're making in the sample of the data before we commit to running the process. Dataiku offers 80 built-in processors, which do simple to advanced manipulations of the data. Everything from find and replace to regular expressions, data cleansing, extraction, geographic data manipulation, creating fuzzy joins between datasets, and more. And if that's not enough, we can add custom formulas in an Excel-like language or code directly in Python. Now let's go back to the entire flow to see some of the other components of Dataiku. As analysts, if we need to join 2 or more datasets, it can easily be done thanks to the join visual recipe. Dataiku gives us a visual UI to choose the type of join among those available. It also lets us define the conditions of the join and decide which columns we want to keep in the output dataset. We can run this join inside the database or through another engine if needed. If we're concerned about the openness of what's been done, or if we want to adjust the recipe through code, we can do so by hitting the Convert to SQL recipe button. Similar functionality exists for grouping, splits, stacks, pivots, windowing, and other common SQL-like functions. Like we mentioned before, Dataiku will always allow us to push the computation to the underlying infrastructure whenever possible. In this project, we've moved data to Amazon S3 and Hadoop to allow for more powerful computations. Up to this point, we've only used the visual tools within Dataiku. But what about users who prefer to code? These users also have a first-class environment in which to work. For them, it is possible to create code recipes in the language of their choice. Here, we've built Python code to combine clusters based on different neighborhoods in New York City. Dataiku also provides starter code to facilitate common actions, or create snippets that can be reused across the company. We can choose to edit our code in a notebook. This opens a Jupyter notebook with the recipe code, where we can interactively test the code. Dataiku allows everyone to work within their own environment and to install the packages they want, giving them full freedom to do the work their way. At the same time, these environments could also be locked down to ensure production stability, or according to any other internal rules and requirements. These red circles are plugins, which have a wider scope than recipes as they are meant to be reused across projects. We can build them ourselves or use those built by the user community to extend the power of Dataiku. This is another instance of successful collaboration on the platform, where data scientists enable analysts to save time by packaging frequently used data processing and analysis logic. Now that we've prepared the data, it's time to dive into the algorithms to train a model to predict taxi fares. Like everything inside Dataiku, we can do it through code or using the visual interface. Let's see how we can rapidly build and compare models to get a first understanding of the problem we're trying to solve. We can choose to train our model directly or use the visual interface to adjust different aspects of the model. Dataiku gives users full freedom to adjust the inputs into the algorithms when building models. The automated machine learning capabilities allow us to train dozens of algorithms using a visual interface while still leveraging state-of-the-art open-source machine learning libraries, such as scikit-learn, MLlib, and XGBoost. We can also create, train, and deploy advanced custom machine learning models using Python or R. For this project, we've tested 2 built-in models, Random Forest and XGBoost, against an imported one named LightGBM, which was built in Python and easily embedded into Dataiku. We can compare their performance on a single interface and get instant insights, including variables importance, viewing the train and test set sizes, and train time. On this particular case, LightGBM performs slightly better than Random Forest. Let's now dive into a quick analysis. Dataiku features ready-made charts and tables designed to facilitate discussion between all potential stakeholders. The short descriptions enable us to quickly understand the technical specifications and instead focus more on what the chart means. Once a model has been vetted, it can be immediately deployed to the flow in a few clicks and used to score new data and deliver our fare prediction. It's time now to deploy and operationalize this project, and for this we have several options. First, let's see how to easily communicate insights internally. One way is to create web apps through Shiny, Bokeh, or JavaScript, or HTML or CSS and host them in the system. We can also share project information and results with both R Markdown and wikis. And Dataiku includes a GUI-based dashboarding environment, gathering charts, data, model reports, static insights, comments, and many other elements into a single interface. Some users also use Dataiku to push data to other dashboarding and visualization environments, such as Tableau or Power BI. The Dataiku automation node provides a way to separate your development and production environments and makes it easy to deploy and update Dataiku projects in production. Models can be exposed as a REST API in just a few clicks. We can test REST APIs inside the system and then deploy using the API deployer, which propagates your API to multiple infrastructure options and configurations, including Kubernetes clusters. The interface enables us to quickly A/B test between models, as well as manage and deploy different versions of each model, all so that the service is always running seamlessly for the end users. Dataiku has been built from the ground up with a people-first approach. As we've seen, the platform enables everyone in the data-driven organization to contribute their skills to data projects. On the homepage, we can see all the projects from our team. On each project, permissions are granted on a group basis, and each user is added to a group. Then, at the project level, we have a view of all the contributors and can trace back each action from the timeline. Other panels allow us to dive into the number of commits in time and the activity of each contributor. Collaboration is eventually reflected in the flow. Engineers establish the connections to the existing infrastructure, while analysts prep the data and build quick insights, and data scientists focus on improving the performance of the models. We've reached the end of this quick tour of Dataiku's end-to-end capabilities, which make it easy for everyone to collaborate on the data science process and move businesses along their journey towards enterprise AI. Thank you for watching. We'd be happy to further discuss. You can easily get in touch with us from our website. You're also now ready to try Dataiku for yourself at dataiku.com/dss/try now with a free 2-week hosted trial. We look forward to hearing from you.